All right, in this video, we're going to take a look at some applications of exponential equations. We're going to start by looking at radioactive decay and things like half-life. And don't worry if you've never taken a course in chemistry or anything like that. You don't really have to worry too much about that for this class. But for radioactive decay and half-life, as time progresses, some elements become unstable and release energy, which is going to diminish how much of the element remains. And the amount of a radioactive element, A, which we use a capital A for amount, at any given moment in time, and we typically use a lowercase t for time, is given by this function here, A of t, the amount at any given moment of time, is equal to A with a little zero subscript, so you can read this as A sub 0, or A naught, N-A-U-G-H-T. Those refer to the initial amount that's present when the time is 0. So it's the amount that we start with times our E, we've seen in the past, to the negative k times t power, where k is called the constant of proportionality. And in terms of what that means is, if we look at a given amount that we start with, let's say t is in years, if we look at the ratio between 5 years, how much we have compared to 4 years, it's going to be the same as the ratio for comparing 20 years to 19 years. So it's constant, so that ratio is not going to change, and since it's a ratio, it's a proportion. All right, so example 2, suppose the half-life of iodine-131 is approximately 8 days. Now, again, you don't need to worry about this number here, this 131. This is an isotope of iodine, I-131. Don't really worry too much about that. What you want to keep in mind, though, is half-life is 8 days, means that no matter how much of this iodine-131 you start with, after 8 days, you're going to have half of that amount remaining. Even if you start with a little, or if you start with an entire room full of it, after 8 days, you're down to half of what you had. So if we have 5 grams initially present, find a function which is going to give us the amount of iodine-131 in grams t days later, and we'll round to 4 decimal places. So we must first find the value of k, the constant of proportionality, and that's going to be a theme when solving these exponential equation applications. So here's again is our exponential function here. It's called the law of uninhibited decay. Since we're losing our amount of iodine as time goes on, and if we start with 5, our initial amount is 5. After 8 days, where t is equal to 8, we're going to have half of that amount that we started with remaining. So half of 5 is 2.5. So plugging in an 8 for t, after 8 days, we're going to have half of this original 5 left, which is going to give us a 2.5. So we have 2.5 equals 5, our initial amount, times e to the negative 8k. So this 8 is the amount of time it takes for this 5 to reduce by half and only have 2.5 left. Now our exponential function is this e to the negative 8k, so we want to isolate this e to the negative 8k, which means if we're multiplying it by 5, we're going to start by dividing both sides by 5, and 2.5 divided by 5 is 0.5, or a half. And with half-life problems, it's essentially going to boil down to this equation. You're going to get a half equals e to the negative, in this case, 8k, where 8 is the amount of time it took to end up with half of what we started with. So now we can take logarithm of both sides, and we'll take the natural logarithm because we are using base e. And the natural log of 1/2 equals the natural log of e to the negative 8k. The natural log of e to the negative 8k is just going to result in this exponent here, this negative 8k. So we have negative 8k equals the natural log of a half, so either multiply both sides by negative 1/8 or divide natural log of 1/2 by negative 8, and you're going to get, when you type this into your calculator, about 0.0866, again to 4 decimal places. And so now that we know what we started with 5 and our value of k is 0.0866, Our function, which we can use to model the amount that we're going to have at any given moment in time, is our starting value of 5 times e to the negative 0.0866 times t. So if we want to figure out how much we'll have after, let's say, 30 days, we could plug a 30 in for t and figure that out. Or maybe we want to see how long it'll take for us to get 1 gram remaining. So we would lose 80% of what we had. We'd be down to 1 gram, and we'd have 1 equal to 5 e to the negative 0.0866 t, which we could then solve for t. All right, so that about does it for this video. In the next video, we'll take a look at using Newton's law of cooling. So I'll